It's gotta be most briny. I played War Thunder. Disgust me.
All right.
She left me at the mall. Shut up.
Wait, here we go. So, step number one. Now, granted, I gave you, he tore it off. I gave you the answers to all of these, yes? Right? So you already know what the answers were. You're supposed to check it yourself. Are there any questions on this? This was three things. This was that 8.1, that two corollaries that you get from the right triangle with the altitude drawn through the right angle to the hypotenuse. Then we have Pythagorean theorem and the converse. And then lastly, we had special right triangles. If there's anything that you're going to forget, you're not going to forget the Pythagorean theorem, but you're going to forget the 8.1, and you're going to forget the special right triangles between now and the test. There are now some people have great memories. I'm not one of them. Some people have great memories. This is the first time ever. I mean, literally ever. But this is the first time this year that we're doing 2 review days for just a chapter test. Chapter 8 is the easiest chapter in the sense of it's tiny little bit about proofs. No proofs today, right? It's all about skills. Well, these were 3 of the skills. Right, and then for the rest of the today, tomorrow, this is just an application of today and tomorrow. We're going to get 3 more skills to add to our total list. So it's about 6 to 7 total skills. If there's a test that you can get an easy A on, it's the Chapter 8 test. But I'm going to warn you, right? If you blew off this worksheet right now, right, you're not doing your job as a student, right? We will do 2 reviews. It's literally going to be pretty much the same paper, what you did, plus the stuff that we're doing now, the trig. We're doing 2 days of it. I will give you 2 practice tests that will look exactly like the test. And then the 3rd day, we take the real test. Okay, please pass the test. All right, and it's the first test. All right, here's your homework for tonight. Once again, this cannot be done without a calculator. Well, so what did people do without before we had a calculator? Well, I will show you today. It can be done by hand, but you need a table. And it's in the book. It's in the book. But no one, it's the 21st century. No one uses the table. Everyone uses a calculator to do this. Right? I'm not gonna collect. I just wanted to see that you have it. So I will give you credit for the worksheet without actually seeing it. If you're dumb enough not to do your homework, well then, may God have mercy on your soul. You're going to fail the test. Requiescat in pace.
Whoa! What language did you just slip into tongue?
You haven't played any Assassin's Creed?
No.
Really?
I've never gotten around to it.
That's good because now you got a whole bunch of good games lined up that you can play if you wanted to.
Yeah, I don't know if I have the money to buy all this.
Well, they offer. I mean, if you pay, some of them end up being free throughout the year.
So
So
like on Steam or is it on console?
console, but no, it's on Steam too. I'm sure, right? All right, you ready?
I'm never ready.
There are only 12 problems. Of the 12 problems, probably half of them you need to calculate. The other half is just a setup. You weren't listening to anything I said, you two, were you? You weren't listening to anything I said, were you? Just say yes, I was not listening.
No.
Okay. I said, I'm going to give you credit without collecting it.
Yes, no, you said you wanted to see it, so I showed you it.
Oh, okay, even better. Now it's my fault, not your fault. Because I was making the assumption that you were about to say, Mr. C, you didn't collect the homework. Now it's my fault. Okay, here we go. Tangent ratio, new word, tangent.
No.
Oh, by the way, we will use tangent again this year, and it won't mean anything what we're doing today.
Yeah.
Okay, we're going to use tangent twice this year. I believe chapter 9 is circles. Somebody flip forward. When we get to the chapter on circles, we'll see tangent again. It will have nothing to do with trigonometry. All right. Oh, it gets really fun. I mean, I don't know. Maybe I'm a geek, but whenever they say, "Oh, you can use a calculator," okay, it becomes fun. All right. Some quick background. Background, right? Background. Stupid mask. Trigonometry comes from the word.
Triangle.
Holy cow, you're a genius. Comes from the word trig and the word, geometry or metry. Trig actually means, say it,
Triangle.
and metry means
Math.
what?
Triangle math.
Good one. Geometry,
Study up.
right?
Study up.
Right? Measure. Remember, I don't know if you remember, those day one of class, I said geometry means we measure geo-earth. You're measuring the earth. Okay? That's where geometry comes from. Trigonometry is you're measuring triangles. Okay, there's a whole branch of mathematics, and boy, does it get complicated, where all you do is measure triangles. And the big question is, why does triangle get love and a square doesn't? Why does triangle get love? We don't have a whole thing of math about circles, right? Circles are pretty cool. Why does triangles get the love? Here's why. Well, the reason is that you can take any shape to include circles and turn them into, well, pieces of parts of triangles. All you need to do is put a dot anywhere inside a shape, connect it to any of the vertices of a polygon, and you make triangles. You take you don't know what that does anybody know what this line is called right here from pre-algebra?
Oh, I remember. That's on the right side.
So single syllable starts with the letter C.
Matrix.
That
Matrix is
start
two
with a
syllables.
C. That's
It doesn't start with a C.
I can drink.
This is called chord.
Oh, it's cool.
If you attach a chord to the center of a circle, you make a triangle, right? So you get triangles even inside of circles. Yes.
I was supposed to have one of those note sheet things.
Thank you, Matt. I did screw up. So what are we doing? We're going to learn something about how to measure triangles, and we're going to have some new words. This is both today and tomorrow.
That picture is a thing of my imagination. That thing is
I
adorable.
don't know what.
Look at his head. He looks
But,
like Michael
so-
Zell.
No. And then over the weekend, some of my exes texted me out of nowhere. Hey, what's going on? Yo, y'all moving mad. One of them was eligible, obviously. She's lost me.
Sorry.
Kick
Kicking deep. All right. So trigonometry has its own set of words. They're new words to you unless you've heard of these things before. It's no big deal. It's just a word, and it has a very easy definition to all of them. So don't panic. You're going to need your calculator, and you're going to have a big but here. And the big but here is that your calculator has to be in something called degrees. You're like, well, what do you mean degrees? Isn't there just degrees? Well, it turns out as you go into higher level math, we get rid of degrees. Next year, boom, we get rid of degrees. Not this year. Some geometry books get rid of them this year. You actually get rid of degrees, and you're introduced to something called radians, R-A-D-I-A-N-S.
Sure, it's familiar.
All
I was on the
higher
test.
level math is not done for geometry. It's not done in
I
degrees.
was on that test thing that we
Done in radians. So here's the deal. The default for your graphing calculator, guess what? You reset your calculator, guess what it's set in? Set in radians. Why? Because no one uses degrees except for low people. No one in higher level math uses anything other than a good calculator. So I can't tell you all calculators, but this calculator, TI-84, which is the one I said for you to buy, its default is radians. We're not going to talk about radians today. We will talk about it Algebra 2 pre-calculus. Our book chooses not to talk about radians. We have to make sure for today's class that our calculators are set in degrees. And this is the big, I wish we just did radians. It would make our lives a whole lot easier. But we don't. So it just always depends. And you'll see it as you take your SAT test. Some questions may ask you what is it in degrees. Most of the time it'll ask you in radians. So you have to be able to comfortably know how to change your calculator from degrees to radians. I'll talk about this calculator first. So to make sure that you are in pre-calculus, there's no degrees, it's only radians. Okay. So to change this, you need to find the mode button. My finger is touching it right now. See the mode button? Press the mode button, and you will see, I think it's the second thing down, is that right? Third thing down. The third thing down, it says radian or degree. I bet yours right now is set on radians, because that's the default. So you need to highlight. You don't have this calculator. Okay. So highlight the word degree, hit enter, and make sure that it is blackened. Right? It goes black, white, black, white, black, white. We good? Has to be on degrees. Other calculators, right? Generally speaking, at the very top, there is an R. It's telling you yours is in radians right now. Oh, I'm not sure where to find it on this one, but I would assume it's under mode. And it's not. Sometimes you will see a button literally called DRG, degrees, radians, and another thing we won't talk about. We have to find the radian button. So on the calculator I just gave you, I guess I should have done this. Oh, the very bottom, right here, where my finger's touching, it says DRG, but it's yellow. So you need to hit your yellow button, right? You see the, I can't tell, is that a D or R or G? That's too small for me to see.
Looks like a D.
If it's in D, you're good to go. But I believe we can change it to R. Yeah, degree, radian, grid, so we want 1. So we're good to go. It was a D. Okay.
Big brain.
Look at the very top and say DRG.
Yikes.
Okay, you're good to go. So that calculator I just handed you, their default is degrees. You're good to go. So I'm not giving you a calculator for the test. All right, so we have now placed our calculators in degrees. We're good to go. Is yours now in degrees?
Okay. No.
Yes. What?
You underestimate me
All right.
for an idiot.
I'm getting it.
Good. So this is one of those things you're going to have to just use mine for right now. We'll look it up like student advisor or something.
I got you, homie.
It's an easy.
I'll put that bad boy in degrees
Okay,
for
alright.
you. Know how
So this is one of those drills you're just going to have to be very comfortable with using. You're going to grab your calculator like from now on, and you got to know whether you need it in degrees or radians. You're going to do the problem. You're like, wait, I got 3.2 and it says the answer is 100 and whatever degrees. You're like, oh, I have it in radians instead of degrees, or vice versa. All right, so what are we doing today? We're going to be dealing with right triangles, and we're going to be measuring the lengths of them. We've already done this 2 different ways, right? We've done it with the Pythagorean theorem, right? If I give you the triangle and I give you 2 sides, can you find the third using Pythagorean theorem? Yeah, a squared plus b squared equals c squared, right? Okay. We learned our last class, or 2 classes ago, we learned that if we have special right triangles, either one of these 2, and I give you 1 side, but this only applies to special right triangles. If I give you 1 side of a special right triangle, you can find the other 2 sides. Okay. Well, there is a third way, and it's the most common. Most of the time, we don't use Pythagorean theorem. We don't use special right triangles. We use trig, right? And trig, right, is how we generally find side lengths of right triangles. By the way, what I'm going to teach you today only applies to right triangles. You can't use this for all triangles, just right triangles. Okay, so here's the setup, box 1. You're going to need to write this down. Box 1. Just quickly draw this triangle in box 1. It doesn't have to be as large as I drew it, but, and all we're going to do is label the side. We're going to give names to the sides. You're like, well, it's a right triangle. I already know the names of the sides.
No, you
Chris, what's the name of this side?
Yes. C.
It's a right triangle. What's the name of this side?
C squared.
True. What's another name for it? 100% true. If it's a right triangle, this side is the. You're like, well, I already knew that. And I already knew that the other 2 sides were called the legs, but we're gonna, because we're gonna do trig, we give them new names. Okay? They are still the legs. We got long leg, we got short leg. Okay, but we're gonna give them names. Oh, by the way, we got this funny little symbol that you saw on your test last week. This is the Greek letter. If your name is Thomas, well, probably not Thomas, but Theodore, that's better. If your name is Theodore, that's the first letter of your name in Greek.
How?
Right? Because that is the Greek letter
That makes it
TH.
Oh.
And this is the symbol theta. Now, why do we put that symbol there? It's kind of, it could be X. It's just a variable. If you've noticed on your graphing calculator where your X button is, look else what's there. It says X, T, because we like T for time, and then look at the next letter that's right there. It's theta, right? It's just a variable. Our book, lots of geometry books will use this. Our book tends not to, and I put it in there because I want you to get used to seeing that. That's just a variable. You see this corner vertex right here, A, okay? So this is angle A, yes? Or it's angle theta. Either one is fine. Now, do you see the one that I labeled? When we do trig, we're never going to be concerned with a 90-degree angle. Everybody listen, this is important. We're never going to be concerned with the right angle. It's got to be a right triangle, but I'm only concerned with the other two angles. You see which one I made red?
Yes.
This one. Okay. What are we going to call the side that is opposite this angle? We are literally going to call it Merry Christmas. Not Merry Christmas, but we're going to call it the opposite side. We're going to call the side that's next to the angle that we care about the adjacent side. Well, why isn't this one adjacent? Because it's the hypotenuse. So we're going to call the side that touches the right angle that is next to the angle that we care about, in this case A. We're going to call it the adjacent side. And we're going to call the one that's opposite of opposite. So this is probably the one time in math when I came up with names that make sense. Welcome to Trig. All right, now I'm going to ruin your life because you ready? I said in trig, do we care about the right angle?
Scott, no.
We don't. We only care about the other two angles now. Instead of making angle A red, I'm going to make angle C red. So we call this one the opposite one, but if I make C red, guess what? Now, this one is your opposite, this one is your, and this one is still, okay, this is box 2. I will let you choose whether you rewrite this or you're like, okay, well, I already got that concept. It's your choice. But I will say this is pretty big. They're going to give you one of the angles. It won't be the right angle. It'll be one of the other two. You have to figure out which sides are adjacent, which side are opposite, and the hypotenuse never changes. Yeah.
So let's say they give us a right angle and an angle C. Can we then use those two angles to subtract both sides from 180 and then get angle A?
Right.
And then just do the original one. Is that possible?
What do you mean the original? We could. Oh, yes, absolutely 100%. Absolutely 100%.
So as long as it's that angle with its adjacent side.
Because we have that third angle theorem that says if you're given 2, you can always find the third. Absolutely 100%.
Okay,
I don't know if you follow what Seth was like. Well, what if I don't ever want to care about angle C?
I don't like that angle.
We could always calculate A because if you give me C, I could figure out what A is. Very true. Okay. But this idea of adjacent, opposite, and hypotenuse, does everybody understand? All right. So if you can handle that, and you can use your calculator, which I'll show you here in a second, you can do trig. Okay, good. All right. So we're going to be talking about something called trig ratios or trig functions. Turns out there's too many of these. It will make your head explode by the time you get to calculus. There's so many of these, right? These are ratios that are formed by the right triangle sides and the angles. So we're going to get ratio fractions that are formed by the sides of the right triangle and something to do about their angles. It'll make sense when we do a couple examples. Boy, are there lots of these. And like I said, your head will explode by the time you get to calculus. My daughter's in freshman year of college right now, and I've never taught calculus. I've taken calculus. I was great at calculus, but I haven't done calculus in many, many years. My daughter comes home and she's asking for help on her homework. I was like, I don't remember those trig ratios, right? There are trig functions. There are so many of these. This year you learned the easiest of the easiest ones, and this sticks with you as well too. The other ones, well, as you go up into algebra 2 and pre-calculus and calculus, you'll be good at them, right? Better than even, some math teachers, because I've forgotten most of these. Just to shock and awe you, this is only page 1, right? Here's page 2, right? All of these, if you take pre-calculus, you will become familiar with. If you go into calculus, there's even more of these.
Yeah, no.
But this year you get the nice, friendly ones. So let me show you where they come from first. All of those come from someplace. I'm going to show you where the easy ones come from. Okay. Remember 2 chapters ago we did similar triangles? Okay. So that would be 2 triangles, right, that are the same shape, just different size, right? So here I got a small one, right, 35-degree angle. It's a right triangle. This one's 35. These 2 are similar, right? Remember we have angle, angle, okay? Remember one of the consequences of similar triangles. If 2 triangles are similar, we can write their sides in a ratio, and they're exactly the same. In other words, if I write the ratio A over B, and these 2 triangles are similar, then A over B will equal, okay? This is the magic of trig ratios right here. Is the fact that if you have 2 right triangles, you got the same angle here, 35, that means that the opposite divided by the
adjacent
is the same for all right triangles where the angle is 35. Okay?
And that's
all right, write this down, box 3. That ratio, that specific one, there's lots of ratios, but that specific one, we are going to give the word tangent. Okay, a tangent. Well, it's a trig ratio. It's got to be applied to a right triangle. You can't apply this to a non-right triangle. And it's the ratio. It just means fraction of the opposite divided by the adjacent. Now, you have to have a specific angle. So I named it for this particular triangle, angle A. I could have said angle theta. Here's the 2 ways you could have said it. You don't need to write both of these down if you understand it. Is equal to the opposite side divided by the adjacent side. And that's all there is to it.
I do have to quickly say something.
Yeah.
So I knew this guy, right? That I worked for his engineering company, right?
How?
This
Keep
guy.
talking.
This guy, he studied trigonometry. He got into the
Trig is the most used math in architecture. It is the most used math in engineering. Trig is used. Calculus is really important. Trig is up there with it.
Yeah, no, like he was in the military calculating.
I use trig in the army all the time.
Yeah.
You can't send a bullet where you want it to go without trig.
I know, right?
Right.
This guy, like, he was completely obsessed with it. He knew the trigonometry and got into a bunch of this stuff, right? But I swear, it drove him mad. I don't work with him anymore because he is utterly crazy.
Okay.
Those are the best.
I thought this story was going to somewhere useful.
No.
Okay. Here we go. So when you're asked to do the tangent, they're going to give you one thing. Look on the board. They're going to tell you which angle. Remember, we're not concerned ever with the right angle, but we're either concerned with C or A, and they could be called any letters, right? Don't get fixated on A or C. But it's going to be these 2 angles of a right triangle. And if you're asked to do the tangent, then you literally just write how long is the opposite side divided by how long is the adjacent side, and that's it. You're like, well, what is this all about? Well, we'll get there, but that's all tangent is. Questions? So guess what the first thing I ask you to do for homework?
Tangent.
Just write that down. Okay. By the way, for those of you that care, the word tangent, we're going to learn later, it means a segment, line, ray that touches a circle in one spot. And if I connect the center of the circle to that green line right there, I will get what's called a tangent. That's why this has the word tangent. Tangent means to touch in Latin, apparently. Okay, so these are the 2 ways that tangent or not. Remember, I said it's either going to be angle A or it's going to be angle C. And on both of these, the opposite and adjacent flip-flop. So if I'm dealing with angle A, opposite is over here. If I'm dealing with angle C, the opposite is over here. Notice hypotenuse gets no love for tangent. Hypotenuse is immaterial for tangent. Very material for tomorrow when we do the other 2 trig ratios. All right, so for this particular one, it would be CB over BA, And for this one, if I'm doing C, it would be BA over BC. Okay? But it's still just opposite over adjacent. Okay. So how does this work? They're going to give you a right triangle. They're going to ask you to set up the trig ratio. So if I ask you to tell me what is the tangent of angle Y, you put your finger on angle Y, and tangent is always, Connor, what's the ratio that you wrote down? You have the word tangent, and then in yellow you wrote, say it,
Opposite.
over. Okay, so if I tell you the tangent of angle Y, what side is opposite angle Y? Which side? We're talking about distances now. What side is opposite? Here's angle Y. What side is opposite? Look on the board, not on your paper. Which side is opposite? 5 is opposite. What side is adjacent? Connor? 12 is the right answer. So it's just the fraction 5 over 12. Is that literally all they're going to ask me to do? At this point, yes. Clearly, we got to do some more because that's not very useful. Okay, Matt, what's tan x? Oh, and by the way, we say tan rather than tangent because we're lazy. Keep talking.
I want to apologize.
Questions on what we just did? By the way, look, they're just reciprocals of each other. It will always be that case. Who's lost? Could you do this? How are you going to screw this up? Because they're going to give you the distance of the hypotenuse, and it's easy to put in the wrong number. So make sure that if you're doing tangent, not the other two, but if you're doing tangent, hypotenuse gets no love. All right, big deal, right? Or no big deal. So once again, just to reiterate, what's truly the big deal is that if you have two different size right triangles where the angles are exactly the same, the ratios never change. The numbers change, but the final answer, if you actually do that math, top divided by bottom, you get the same number. Literally, you get the same number. If angle A equals angle R, and angle C equals angle T, since it's a right triangle, right? Then by the angle-angle similarity, the third triangle is the same. Therefore, they are similar. And therefore, the ratio of the two sides, A over B, needs to be the same on both ones, so we get R divided by S. I didn't do any division here. I just simply wrote the previous one as well. We wrote 12 over 5 or 5 over 12. We didn't actually divide 12 by 5. Guess why you have a calculator in front of you? That's what we're about to do. And we're even going to make it easier because there's literally a button on your calculator that does that math for you and tells you what 5 divided by 12 is without ever touching 5 and 12. Your calculator already knows what 5 divided by 12 is without typing in 5 and 12. Do you know how? Because on your calculator there is a.
It's got a memory card.
It's got a tan button. It already has memorized what 5 divided by 12 is because of the tan button. Because it knows for a tangent, you divide opposite divided by adjacent. Okay. So this is a huge deal. Huge. You can't see it, but you will here in a second. Now, I said your calculator already knows what 5 divided by 12 is because on page 311 in your book, your calculator has this table in its memory. It knows that if you're dividing, for instance, a certain number by a certain number that is related to a certain angle, that you get this table. You can't see all this stuff, but it's the other two trig functions as well, too, sine and cosine. But it already has this, it already knows what 5 divided by 12 is. It's in its memory bank. Okay? So when you hit the tan button, all you're doing is saying, calculator, think of the math that's already been done. What is 5 divided by 12? Okay. Some of you are still underwhelmed. I'm sure Danny is underwhelmed, right? So let's calculate some side lengths when we don't know one, right? Using trig. So this is my Oh, it's for you, Danny.
My boy Danny.
Right?
My Google
Hey,
slides.
Danny, what is that? Okay, so let's say, 700 years ago, when you were an aggressor and you wanted to take over someone's castle, you first needed to,
Ask
you
politely.
needed to knock down their walls so you could gain access to their castle and steal all their money,
Well, that's
right?
not nice.
So back then they used Danny A. Well, you get close to the thing, all the arrows are going to kill you. So what did you use first? Or,
But you can't get to the walls.
Use the shields.
okay, they catapults and trebuchets, right?
Turn them
So
against each
you
other.
take a trebuchet, you stand away because trebuchet can throw a rock farther than an arrow, right? You can knock down their walls and then you could run really fast and hopefully you don't get hit by their arrows. Plus, if you knock down their walls, maybe you knock some of them down. So this is literally, we've been using trig since the Greeks. This is how they would use trig. Well, here's their castle, right? If they get too close to the castle, they get rained with arrows, right? So they don't put the trebuchet right here. They put the trebuchet out of range of the arrows. Okay? And then what they would do is someone on the trebuchet crew, they would say, hey, Joe, right? Or maybe it was Danny.
Joe who?
Hey, Danny, I want you to go about 500 feet to the left of me and stop there. And I want you to bring with you a compass. Okay? Or a protractor. Okay? So they would literally send someone, because the arrows couldn't go this far, right? They would send someone, and it was right or left, about 500 feet with a protractor. And they would say, once you're there, take the protractor and tell me what is the angle measurement from here to the castle wall. And then record it. And then come running back. So let's say it was 56 degrees. Great. So what? If they make a right triangle out of this, you see the right triangle? They can now figure out, without walking to the castle, how far this distance is. Why is that important?
So they can
Yeah, but why do they care about how far it is from here to the wall? In order to hit the wall, if you remember last year when you made trebuchets, or whatever year that was, depending upon the weight that you put in the trebuchet is how far the rock goes. The heavier the rock, further it goes. Well, they don't want to send 4,600 rocks till they find out the perfect weight of the rock. They can use math to figure this out and get it the first shot to hit. That's kind of important in battle. Because while you're going to sit there and send 4,600 rocks, they're not going to sit there and say, well, yeah, just keep throwing rocks until you hit me. They're going to send people to kill you. If you can instead use some math to figure out immediately how far that is, you can have that first round hit them before they're even awake. Hey, roll that sucker up during the night. First light, drop your first rock, and boom, you're in the castle. And by the way, this is literally what they did. So they used trig. In fact, they used tangent to do this. So how did they use it? Well, give me the tangent of 56. That would be the opposite divided by the adjacent. So what's the opposite here? What is the adjacent? So that's what they did. Smaller picture. That's what they did, literally. Tan theta, that means that whatever that degree is, 56 in this case, will be equal to x divided by 5. Watch the math. Let's solve for x. What do we got to do to both sides? Everybody see that? What happens to the 500s over here? Now grab your calculators, smarty pants.
Oh.
Type that into your calculator as it appears. 500, 10, 56, and hit enter. How far is the castle?
Oh. Wait.
Boom. Castle's down on the first rock. Boom. Okay, yeah.
But will
Throw a
the
heavy
wind,
enough rock and wind will have, will definitely affect it, right?
will the wind affect it? Like,
Sure, the heavier the rock, the less effect it would have.
oh,
Okay.
yeah.
But I'm not joking when I say they used trig. This is literally what they did. Now, did they have a calculator? No, they had that table that when you looked it up, it said tangent 56 is equal to point whatever, and then multiply that by 500. This is what we're doing. We're not knocking down walls today. We're just doing calculations. So here we go. Box 5. Let's do this. Let's do this. By the way, this is how you find the distances between something that you can't actually measure. How far is the nearest star? We've never sent anyone to that star. We simply use a little bit of trig. Literally, it's the same calculation. The Earth is here. The Earth goes around the sun. If you wait 6 months between the Earth, you're on the opposite side. You can figure out how far a star is simply by taking the angle measurement. We never go to the star, but we can tell how far it is using a little bit of trig. And this applies to any time you can't literally measure a distance. You use some trig. Hey, how high is the rocket? You use trig. Okay, so here we go. Here's your first one. This is box 5. You got to do this. Okay. 56 degrees again. The tangent of 56 would be opposite over adjacent. What's my fraction?
Y over 32.
Okay, so tan x, you can call it theta, you can call it any variable you want, would be opposite over adjacent. So tangent of 56 would be y over 32. It's the same algebra now every time. How do we get y by itself?
By times 32.
Both sides by
32. And then you get 47.
32's cancel.
You get 47.
Stop me if I'm going too fast. Then you grab your calculator and you literally, if you have a TI-84, you don't even have to put a multiplication symbol here. You just type it in the way it appears. So, and by the way, this will always be approximate. This will not be, you'll never, except for a couple times where you get an exact answer. Therefore, how long is y?
47.
Now, I haven't looked at the homework tonight. Micah, what does it say? Round to nearest 10th? 100th? Round to nearest 10th. All right, who's lost? Hey, easy or complicated? Why do they keep this from fourth graders? A fourth grader could do this. Because this is kind of like magic to a fourth grader.
I mean, there's no 9:30.
Fourth graders don't know anything about similar triangles, so we can't. It would be magic to a fourth grader. To a 10th grader, it's like an application of geometry.
To a fourth grader, they're not exposed to letters
All right.
being numbers.
I flipped the triangle upside down. The tangent is still the tangent. Cadence. What's the setup? It's always opposite over adjacent. Okay, so tangent 42 would be equal to the opposite over the adjacent. So in other words, x over 12. Anybody lost on that? It's box 6. Okay. And for those of you that see the pattern, you could probably grab your calculator right now because the pattern doesn't change. Guess what it sets up to?
10.8.
It's always that times that. For this relationship, we're going to show you a different one here in a second. So we multiply both sides by 12. We grab our calculator, and what did you say the answer was?
10.8. Oh.
It's like, okay, this is why I like trig, because it's an easy concept, right? It is higher level math for sure, right? But it's easy, and you get a calculator. All right, that was the easy one. Notice each time for the tangent, the opposite was the variable. What would happen if the
Adjacent.
That's the one we're about to do. This is the hard one. All right. It's just an algebra problem. So set it up. This is box 7. Make sure you do this. Give me the setup. Equals 14 over x. You see what he did? Now notice the problem is the variable's in the bottom. All we're going to do is some algebra. Hey,
Copy dot flip.
we could, right? I'm going to choose to say let's multiply both sides by x. Okay, watch this. I'm going to there's another option. I think this is the easiest one. Let's multiply both sides by x. What happens to x is on the right side.
Go away.
And so you're left with,
X
well, then what? How could you solve for x? Well, how is the x attached to the tangent? Attached by multiplication. How do you get rid of multiplication? So what am I going to divide both sides by? This is where you join the club. Welcome to higher level math, which you don't even know you could do, but you can do that.
Oh my God.
Hey, what happens to tan 15 on the left side?
Death.
and then you're left that x is equal to 14 over tan 15. Type that into your calculator. You're like, what? Type what? Type that into your calculator. 14 fraction bar means 14 divided by tan 15.
Do be 3 point. Oh wait, I did 4 instead of 14.
What'd you get?
I don't like the world anymore.
Danny, you got this? Is this easy? And I'm not, hey, I am seriously not joking when I say this is crazy. You will see now that you're in the Trig Club. This is like what everybody, engineers, scientists, everyone uses Trig all the time. Right? You want to show like on some stupid television show when they show some guy doing math. Guess what's always on the board? Trig, because it looks like it's complicated. And then you learn, oh, well, it's not that complicated. And then you're like, well, the TV's lying to me. Right? Kate, you had a question? Okay, we good? Let's do one more. Box 8. Yeah. Micah. Okay. Wes, give me the setup for this one.
13 over x.
Tan 37.
Equals 13 over x.
Okay. And then we're going to do that same drill. We're just going to solve for x. These only come in 2 flavors. The one we did before, the easy one, and this one. They're both just a little bit of algebra. What are we going to do first?
A little bit.
It's just 2 steps. What are we going to do to both sides first? No, we're going to multiply first by x, Matt. Because we got to get x from the bottom. What happens to the x's over here? Now what are we going to do? Now some people can see the pattern. Tans cancel. And then what will happen is after you do about 20 of these, you'll see the pattern and you won't do the algebra. You're like, well, I know what to do here. But you do still have to do that first step. Is the one where the x is on the top or the one where the x is on the bottom? When the x is on the top, you multiply the tangent by whatever's on the bottom. When the x is on the bottom, then you take the top and divide it by tan. Right? Hopefully that makes sense.
9.7.
Right. I got 17.3 is what I got.
Yeah, that's what I got too.
By the way, the rule with the calculator is to always do the calculation twice because you got fat fingers, right? You can always touch the wrong key by accident. So always do the calculation twice. Yeah.
So this is where you can just like use your 2 angles to determine the last angle and just avoid this mess, right?
If you always want
yeah.
the variable on the top, yes.
Okay.
But you tell me, you still got to do that one extra step. What Cage was saying is that she's already seen the pattern. X is on the bottom. She's going to do 13 divided by tan 37. She's already done the problem when you're thinking about it. No. If x is on the top, then it's bottom times the tangent. Okay. As soon as you notice that pattern, then this can become a very quick operation. By the way, this is you're going to see this on every single state test, the SAT, because these basic trig functions are the ones that are always tested. Very rarely do you remember those double trig or double angle trig functions. Like I got to think about that one. I haven't taught that in years. The next year on Teach Pre-Calculus, I got to remember what that one was. But this one, no one forgets this one. All right. Quick exploration. Hey, type this in your calculator. 10.0001. What do you got? Quick exploration. A really, really, really small number, yes?
Yeah, that's not.
Yours is probably scientific notation.
1.75.
Hey, do tangent 45. Why is tan 45 1?
Because it's cool like that. It's here 45.
Hey, tangent 45 is a isosceles triangle. Therefore, it doesn't matter what this side is. If it's isosceles, it's 5 over 5. That's why tangent 45 is 1. It's the only one, pun intended. It's the only one for tangent where you get a nice friendly number. The rest of them are all really, really ugly. Hey, what do you notice is happening to the numbers?
It gets increasingly bigger by like
So
7.
take a guess.
It's like that's like 7,000.
It's a really, 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 really big number. So tangent, they approach 0 and they go all the way to infinity. Approaching infinity, I should say. So for tangent, you can get any number up there. No, at least on that yet. no negative numbers. Okay. All right.
Wait.
Yeah.
So when you're getting up to like 360 degrees, tan 360, that's when you're approaching.
So we do. I'm gonna go off on a tangent here. Instead of saying 360 degrees, we would say 0 degrees.
Okay, so how about 357?
Then we would say 3 degrees in the opposite direction. You can type it in your calculator right now. Do it. Tan 357. Let's say. What to say?
I got -0.
So when you think about it, we're going in the opposite direction. That's why. So we could do. You could also do -3 degrees, and you get the same answer.
Error in my calculation.
All right. I do have to finish this. This is the last thing. Inverse operations, right? Inverse operations, right? The inverse of addition is,
Subtract.
okay, the inverse of tangent.
Multiply or something?
Look above the tangent button. What do you see?
Inverse.
I see an arrow button.
You see above the literally written above.
Whatever it is.
You see tangent to the
Negative.
-1. We're going to do 2 minutes. We got to finish this. All right. The last thing is this.
Oh my gosh, I got
The inverse of tangent. Stop. We got to finish this. It's called. This is red inverse tangent. Inverse tangent. We're not done. We got 2 minutes. So, inverse tangent undoes tangent. So how is that useful? Hey, look. Now I don't know what the angle is. We still set it up exactly the same way. So tangent x would be equal to 3/3. Do you see that? But x is now inside tangent. How do you get rid of tangent?
You divide by tangent or?
Inverse tangent.
Yes.
How do you get rid of squaring? Pay attention. You're going to lose it. To get rid of squaring, you take a square root. To get rid of square root, you square it. To get rid of tangent, you do
Inverse tangent.
inverse tangent. Now, I'm going to show you how it's written. This ain't what you're going to type in your calculator. So to get x by itself, we need to do the same thing to both sides. We need to do inverse tangent to both sides. I said I'm going to write it, but you're not going to actually do this. You're simply going to take your calculator. Hey, these cancel each other out, and you would be left with x. Now take your calculator. You need to do inverse tangent of 3 divided by 3. Do inverse tangent of 3 divided by 3.
Oh my God.
Matt, do this. Chris, do this.
It didn't work.
Yes, it did.
No, it didn't. It said error.
Did you put a close your parentheses? I bet if it didn't work, you didn't press inverse tangent. And you got 45. There you go.
Yeah, but then you get
All right. We got to do box 10. We'll call it a day. Hey, on the previous one, where was the x? On a side. Now where is the x?
Inside.
When it's on the inside, when you're finding an angle, you use inverse tangent. When you're finding a side, regular tangent.
You have to put the whole.
You do. All right. So the setup. Tan x is equal to that number, opposite, divided by the adjacent. To get x by itself, we got to use inverse tangent. When we're solving for the angle, we're using inverse tangent. When we're solving for a side, we're using regular tangent. Danny, this doesn't work if you don't have the calculator in your hand, you're doing this. So now, I'm going to write what it looks like. You're actually not going to do this, right? You're just going to grab your calculator. Inverse tangent gets rid of the word tangent. We're left with x is equal to that mess right there. So inverse tangent, 47.44195 divided by 32. I really tried to make this one be the opposite of the first one we did. Guess what the angle was on the first one we did? We're not going to have the castle wall. It was 56. 56 degrees.
Oh, I remember 56.
So I tried to make it 56, but you still need more decimals for a lot of calculators. Did everyone get basically 56?
Yeah.
All right. Last thing, sides, tangent, angles, inverse tangent. Yes? Hey, when I walk into your classroom, Scott's classroom during student advisement, if you haven't done your homework, right? I'm serious. You need to ask questions. All right.
I'll have a question.
Leave the calculators in this box right here if you got one. The box on Chandler's desk.
It's okay. Should I get a TI-84?
It is entirely up to you.
Or you
If
could get
you can
Zelda on
afford
the-
it,
on the
and your
TI
parents are gonna
84.
freak out. I'm gonna just say, I would get one. It just makes
It's
your
on
life a whole lot
Chandler's
easier.
Okay, I can afford it myself.
Yeah,
Yo,
it's,
Matt.
So,
plus
you
it plays
could-
better games than that finding calculators.
You could get Zelda on TI-84. That's what
what the
landed.
crap, really?
That's what landed last year.
Yeah, you can play FNAF too.
All right, e-learners, anyone live?
Yes.
No one. If you have any questions, you probably might have one on this one. And if you do, just send me a chat or an email.